Halo, Assalamualaikum. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. Today I would like to explain the outline of our online lecture during the COVID-19 April 13 until 30, 2020. Our lecture is the second calculus in the International Undergraduate Program of Faculty of Mathematics and Natural Sciences, Gadjah Mada Universty, Yogyakarta. As we knew that from the latest UGM's Vice Rector and Dean's announcements that the teaching and learning process must be via online, it must be done work from home, must be finished on April 30, and final exam must be between 1st and 15th of May. So actually, we only have 3 weeks for finishing half semester after mid-test. Our lecture will be 6 sections. The first section is on April 13th. The second session is on April 14th. The third session is on April 20. The fourth session is on April 21st. The fifth session is on 27th of April. And the sixth session is on April 28th. The topic to be discussed will be focused on the application of definite integral. Of course, there are many applications of definite integral, but because of the limiting time, we only want to discuss about 6 sessions. The first session is on April 13. It is actually 100 minutes. We would like to concentrate on the discussion of area in Cartesian product. In Cartesian coordinate. The area in Cartesian coordinate can be described by the following way. First, we have a region, the blue one, the blue region or the blue area. The blue area is restricted by the x-axis. X is equal to A, x is equal to B, and bounded above by y is equal to fx. This is the simple one. By using this region, we would like to find the formula of the area. Secondly is that we have the area between two curves. The area A, for instance, lies between the curve y is equal to fx and y is equal to gx, the x between A and B. We also want to discuss about the formula, how to find the formula of the area of the A. This is actually the area in Cartesian product. Secondly is about the area in polar coordinates. Yeah. The area can be also described by the following way. First, we have the theta is equal to alpha, the theta is equal to beta. And the A lies between the 0 and the equation R is equal to f theta. So this A is the area, the flat area in polar coordinate. We would like to find the area of A. The formula of the area of A can be described by the definite integral. We will discuss it later on in detail. Thirdly is about the volume. The volume of solid revolution in Cartesian product consisting of two things. First is this method or chakra method, and secondly is shell method or methode kulit. On the third session, we would like to focus the this method. We can describe the this method by the following way. First, we have actually the R. What is the R? The R is actually the area restricted by the x is equal to A, x is equal to B, and above restricted by the curve y is equal to fx. So this area, we focus on this area R. If the R is rotated one round surrounding the x-axis, then we have the solid revolution. The solid revolution. Benda putar padat. Solid revolution mean benda putar yang padat. And in this section, we would like to find how to make formula, how to formulate it, the formula of the volume of this solid revolution. For example, if we have the area R restricted by x equal to 0, x is equal to 1, and above is restricted by the function y is equal to the square root of x. The area look like this. If the area is rotated one round surrounding the x-axis, then we have the third picture. Actually, the third picture is also solid revolution, obtaining by using rotated the R here one round surrounding the x-axis. In the fourth section, we would like to discuss about the volume of the solid revolution in Cartesian coordinate, but with cylindrical shell. In bahasa Indonesia, it is called kulit silinder. In principle, if we have the area, for instance, the dash area, the area restricted by the x is equal to A, x is equal to B, and the y is equal to fx. This, but we would like to integrate not with respect to y, but with respect to x. Once again, we will integrate it with respect to x, but we rotate it with respect to y. That means the cylindrical shell. So this region is rotated with respect to y, one round, but the integration with respect to x. As we see in the picture, if we rotate this area one round surrounding the y-axis, we have the solid revolution like this. But later on, we would like to find that the integral is not with respect to y, but with respect to x. So in principle, the cylindrical shell for the solid revolution is actually a certain region rotated with respect to y, but the integration is with respect to x. In the fifth session, we would like to find the formula of the volume of solid revolution in polar coordinate. This is not easy, of course, but we can manage in the fifth session. For instance, if we have the G is actually the area restricted by the theta is equal to alpha.